All right, student, hello. Mr. Murphy here. Let's go for our first lesson, Module 1, Integer Exponents and Scientific Notation. Topic A is lessons 1 through 6, exponential notations, multiplication of integers in exponential form, numbers in exponential form raised to a power, numbers raised to a zeroth power, negative exponents, and the laws of exponents, and then the proofs. We may not do 6. So our standard for all of these is to know and apply the properties of integer exponents to generate equivalent numerical expressions. So know and apply are things you're doing. What are you doing to? It's with the properties of integer exponents, and how are you doing it? What is the end product going to be in green? Equivalent numerical expressions. So for example, 3 to the power of 2 times 3 to the power of negative 5, an equivalent equal, right? An equivalent, that's the equals, numerical expression is 3 to the power of negative 3. So they're equivalent and they're numerical, so they've got numbers and they're expressions. So this is an expression on this side of the equal sign. This is an expression on this side of the equal signs. And the equal sign says they're the same. They just look different. This could also be equivalent to 1/3 to the power of 3, which is 1 over 27, or 1/27. All right, so let's take a look at those a little closer. Topic B, magnitude, estimating quantities, scientific notation, operations of numbers in scientific notation, efficiency of scientific notations, the choice of units, and comparing numbers written in scientific notation and interpreting scientific notation using technology. All right. And that is going to be these standards: use, estimate, and express. What are we expressing? Numbers with large or small quantities and how many times they are, as single digits times an integer power of 10, or one is more than the other. So an example of this is scientific notation would be 3 times 10 to the power of 8 is the population of the world, while 7 times 10 to the power of 9, 3 times 10 to the power of 8 is the population of the United States, and 7 times 10 to the 9th power to the power of 9 is the population of the world. I'm going too fast, I'm getting confused. So you determine that the world population is 20 times larger than the population of the United States. So 3 times 10 to the 8 is 3 times 10 to the power of 8, which is 10 times 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 10. Big number. And then 3 times that. 7 times 10 to the power of 9 is 10 times 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 7. So there's one more times 10 there, and then a times 7. And if you put all of those out and did 7 times 10 to the 9th divided by 3 times 10 to the 8th, you would get about 20. And we'll figure out how to figure that stuff out during this part. All right. Also, the other thing is you're going to perform and use and choose operations in scientific notation units to express the numbers as decimals and scientific notations, and actually choose the appropriate size of them. You will also interpret what scientific notation is generated by technology, because sometimes you see when you put big numbers in your calculator, it says like e to the E4 or whatever. That has a specific meaning. We'll talk about that. All right. When we get to the end of this, you will be able to fill in all of these boxes with different numbers, and all of the answers will be the same. So 2 to the power of something to the power of something will equal 2 to the power of something to the power of something over 2 to the power of something to the power of something, which is also equal to 2 to the power of something times 2 to the power of something, which is also equal to 2 to the power of something divided by 2 to the power of something. So that's what we will learn by the end of chapter 1. All right? We'll start this in just a second.